Welcome, everyone. This is the NeoLoad 6.8 webinar. Today, we're going to talk about what we recently released to the market and give you guys a demo of the new features. Just a couple housekeeping items. So this session is being recorded. We do have a discussion chat panel that you can use. And we will have some Q&A at the end of the session. Feel free to type your questions or comments at any point during this presentation, but we will be addressing things at the end. We're going to attempt to do a quick poll just so I can get a better sense of who's on the call and where you guys are coming from, so I can better tailor this going forward. If you guys don't mind, just two quick questions, if you could answer them. We're experimenting with this feature, so we'll see how this goes. Okay, great. And the next one? And there's just one more poll question. Thank you for the first one.
You know, Kristen, what's nice about these polls is we're engineers and we're testers. We get to validate our assumptions about things in everything we do.
Exactly. Okay, thanks everyone. So quick introductions. My name is Kristen Webb. I'm the Director of Product Marketing here at Neodis. And I'm going to be talking about just what's going on in the market that Neodis is responding to and how we're specifically responding to it in this release. Paul Bruce is also on the line, and Paul is our Senior Performance Engineer here. Paul is going to dig more into the technical details and do a demo. So you guys may have heard of Bimodal IT. This is a term that Gartner coined, and it's used to describe what's been happening in the market for a very long time, which is most enterprises have two different modes of developing applications and two different types of applications that they use those approaches to develop. Mode one is typically referred to as, the Waterfall traditional software development practice, and that's typically used for the end-to-end applications, the big legacy applications or installed applications, things that businesses use to run their internal operations are typically in mode one. Mode two is more about, being agile and using that process in DevOps, continuous integration. It encompasses things like shift left and API testing. And this development approach is more often used for, more innovative applications, customer-facing things, how to get to market more quickly and be more competitive against your consumers. So what's important about this approach, this terminology and this way of looking at the world is that Neodis is very aware that these are two different approaches that are both important and are both going to be around for a long time. And the way NeoLoad is responding is we're making it easy to do performance testing regardless of which approach that you're using, regardless of what type of application you have or APIs and microservices in your application architecture. So with mode one, we're all about improving our integration with legacy and modern technology stacks in the 6.8 release. And I'll talk specifically about how we're doing that with Tosca by Tricentis. They have SAP GUI testing tools that we are now integrating with. We also have some updates to our data exchange API. And then in mode two is, again, it's about shifting left and doing testing as code. So we'll talk about how we're enabling test design as code in an Agile environment. There are a couple enhancements that Paul will also cover. So for SAP, for those of you on the call who use SAP applications or have developed them, there's a lot of modifications that we make to SAP apps, and a lot of times it can result in a lot of code changes and frustrations around how the application winds up performing, or getting it up installed and meeting user and customer needs can be pretty frustrating. Like I said in the last slide, with SAP, you have new deployments, you have customizations, upgrades, cloud migrations like to HANA coming, and throughout, even though SAP has a packaged application, it has tons of highly customized code in it to make it work specifically for each integration, and that can lead to a lot of bugs. So what we're doing with our Tricentis integration is making it easy to take these functional test assets from Tricentis Tosca for SAP applications, and this is specifically focused on the GUI applications, and convert those test assets into performance tests with one click. So this is a major win in terms of productivity in designing test cases. This is, for those of you on the call that are existing customers, this is very similar to how we integrate with Selenium. We take Selenium functional test case and we convert those assets to performance tests. The difference here is that Selenium can't test SAP applications, so this is broadening what we cover in the market. And this is available today on our labs page. So this is really going to help with collaborating as a team as you share assets, with the rest of your QA team, and reusing things that you already have. This is a quick animated GIF to show you how the two tools work together, NeoLoad and Tricentis Tosca. It's very quick to import that test from Tosca into NeoLoad and convert that into a performance test. And Paul will get more into this when we go to his part. So what I just talked about was how we're continuing to integrate with, in the enterprise, other testing tools to help with those end-to-end application testing like SAP application tests. Now I'm going to talk more about shifting left, which was that mode 2 that I talked about in the beginning. And shift left is important because for organizations who are doing Agile or who are planning to do Agile, they need a way to test performance as code. And so now NeoLoad is giving that option. Why is this important though? Really quick. It's important to test performance very early on at the API level at the developer or tester's individual machine, because when you catch a bug early, it's easier to fix and it's less costly in terms of the brand, the user experience, but also the time it takes to fix and re-release software after it's already been released to the market. It's much more costly down the road. So we have a new feature, it's called Test Design as Code. This is continuing on with a feature set we've already started releasing from past releases, which is giving our users the ability to create and update and maintain performance tests within an existing developer environment. This could be from Swagger or an IDE like Eclipse. The idea here is that within your CI toolchain, you can use your existing tools to invoke those performance tests, define them, and create the test population, view, path, transactions, the parameters, and the settings right from the code. And the benefit of this is that it's more productivity because it's working in performance testing into the way that you develop your code today and automating that within the CI pipeline.
I mean, we're seeing this more and more with, I mean, I'm constantly on the phone with customers, helping them figure out how to do some of these things, maybe particular to NeoLoad, but also in general, a lot of people reach out and ask us, you know, the more we talk with them, they ask us for our opinion about this or that, or how to fit smaller, more frequent testing into their existing processes. And as you know, as a lot of you folks might know, it's very hard to move a mountain, right? So an organization and the processes that are baked in can sometimes be really complicated. So that's why we work really closely. And the outcome of that was that we heard that people want to be able to express their tests, not just a specific set of people like developers, but in general, the market is moving towards being able to open up code, being able to put that into repositories, be able to track it, version it, combine it together. And so we looked at our testing approach and we realized we have a great opportunity. I'm going to hop out real quick and kind of get to the point here. Instead of using just a graphical interface to describe the various elements that go into load testing, we've now taken an approach that allows you, speaking of bimodal, to be able to satisfy the needs of folks who want to use that low-code approach, a graphical interface to describe their tests like you know and love, but also to be able to express your tests in such a way where if, let's say, you want to build out a set of scripts and combine them dynamically, that you can do that at runtime. So I'm going to hop out here and just make sure my screen works. There it goes. So let's start at the very top, right? What is driving the notion of creating these tests in code? Is it people that just want to script their stuff in a different way? Why would anybody want to do things differently if it didn't have a value? Really, ultimately, the reason why things are turning more towards code these days is because it fits into an automation motion, right? An initiative. That's why we put things down in code so that they can run on computers, you know, and so that they can run on our behalf in an automated process. So what we're seeing here is a Jenkins pipeline that I've run, and I actually want to kick this off as well. This is just using Blue Ocean. Again, we support a number of different CI systems. I just use Jenkins because it's the most predominant, and because they've got some pretty graphics here. This is the Blue Ocean plugin, lets you see the steps and the stages of the pipeline. But let's back out into something that might be a little more visually familiar to you. We've got a classic job here, and as you can see, I've been running some pipelines here. I had a little bit of problem, I think it was last night, but you can see that we get sort of the job history here. If we go and we kick this test off, I want to show you what happens and then kind of show you how we got to this process. So I'm going to kick that build off. Obviously, this allows the automated process to do a lot of things. For instance, we work very well with Docker containers because we ship them for both load generators and controllers. You know, you probably all know that there's the big bad in the market that maybe might provide the load generators, but really is a sticking point around the controllers in terms of licensing and packaging and all sorts of things. And you know what? We're not like that. We care about you getting the testing done. And a lot of organizations are moving to Docker. So we publish Docker images for both our controller and our load generator that you can feel free to either pick directly out, or later on, if we have time, I can show you an example of how we can layer on top of the base images here things like how to integrate into Jenkins. So that's what you're seeing here is a console output of the process that I just kicked off. Now it goes through and it does a lot of stuff here, but this is not how we describe. These are the advanced logs that come out of the process. What it's doing right now is it's running a test, a little tiny little API test. And if we bounce back to the Blue Ocean visualization here, you'll see that it's going through a standard process. The standard process driven by an automated CI system, as a lot of our more enterprise customers are starting to really push towards, is the ability to be consistent. Consistent in your expectations, consistent in your execution, and consistent in the results that you get out, how you interpret those results. So what I've done is I kicked off that pipeline that has caused NeoLoad to use some Docker containers to start a real live load test. If we actually look at some of the build output there, you notice that it gives us a NeoLoad web report that we can actually open up and see what was going on there, what's actually going on there. In the meantime, this system is also letting me know, just happens to be through Slack, that these things are being kicked off. They're being started and they're either passing or failing. And I would say that that is really the true sign of fast feedback. If you can't do this with a monolithic load testing tool, then you're missing out. You're missing out on a conversation you can actually have with product teams on how to provide them data that really affects their decisions on a day-to-day basis. So what we have here is that little tiny sanity check that we can visualize. We can go into specific values on transactions and requests that were made to APIs. It's just to make sure that we have just enough of an piece of information that allows us to move forward in the decision-making process. So bear with me just a moment here. There we go. It's also started the next level of testing here. As you can see, I just got notified that a new test started. So it was able to go through that sanity check and start the next phase of testing, which is a full end-to-end testing, right? So these are the types of things where we really do need assets where somebody doesn't have to open it up on a desktop, where somebody doesn't have to go and play around with specific configuration points. For those who are familiar with our low-code approach, what I'm talking about is things like runtime parameters, how long to run the test, how to ramp it up, what populations, what types of scripts we're running, and on what infrastructure we're running those tests that produce load against our system. These are configuration points where folks who prefer a low-code approach have the option to do that graphically. We've got one of the most intuitive, quite frankly, I think it's one of the prettiest, and obviously most visual ways to structure your load test approach. This is what we've had for many, many, many years. But if you think about it, there are other people involved with your tests, right? Particularly people who aren't turned away by this level of detail. In fact, we sometimes need this geeky level of detail to figure out what's going on, what might be happening. So speaking of what's happening, it's launched a full end-to-end load test that's actually testing a website that I have here. And we can open that URL immediately and open up those test results. What we'll see here is that it's ramping up to a certain volume of testing. I just happen to be running this little example on a small little Docker host, so I'm not pushing it too much, but again, we can test into the order of hundreds of thousands. We've even gone so far as to test into the millions with a number of different customers that needed it. In most cases, particularly in the early testing that you might do, particularly stuff that's driven by CI in order to provide the feedback to dev teams immediately, this kind of stuff is far more smaller, than maybe 50 VU, 100 transactions per second. That's the kind of stuff you just want to check on a regular basis. And so what we see here is a test that's running, that's providing a certain amount of load. We're getting some basic metrics back now. In the meantime, we can actually go and select this in a dashboard. And we can focus the dashboard not on a previous example, but on the current one that's running right now. And I want to show you a couple of things that are going on here. The goal of load testing is often to fault isolate, right? To either verify that a baseline's hit, to figure out where your infrastructure is falling down, but more importantly as a tool to shine light on specific elements of your application. And whether you're doing an API test, where the API hits a number of different third parties, and that can become questionable, like which third party is causing the delay, or whether you're testing an end-to-end application, you still need to be able to get to various levels of metrics across the stack of technologies that you're using. The first and obvious place is you want to make sure that your test itself is running on appropriate hardware so that maybe you're not stressing the load system and causing issues to occur there. Now, as you can see, I have a tiny little cluster here, and I might argue that I'm pushing it a little too far with the load infrastructure I'm giving. So that gives me the first immediate feedback as the performance engineer that I maybe need to rethink the resources I'm putting to actually accomplish the job of objective analysis of what the throughput is of my target system. That would be the first graph here, where I'm just looking at basic load infrastructure volume metrics, right? I can get those, a whole bunch of stuff, maybe throughput, warnings, errors, those kind of things. I can get them very easily and drag them onto the graph. In this case, maybe throughput, for instance. If I want to throw that in there just to verify that there's no bottlenecks that are going on in the throughput between my load infrastructure and my system. We can visualize that through what we call NeoLoad web. That's what you're seeing here. And we can do that in real time. This is actually updating the graphs based on the test that I'm running right now. So whether it's you running a test on behalf of somebody else, making sure that those test results are happening, the execution is happening properly, and then maybe sharing those results to somebody else, or literally sitting with your dev team, because maybe this is not the first time you've run this test. Maybe this is the second time you run this test, or the third time you've run this test, because they found issues the first time around. And they need to run it again to verify that their changes actually had an impact, a positive impact on your system, right? So whether it's you doing this and then handing it to somebody else, or whether you're sitting directly with the people that can make a difference, the operations, the development, other performance engineers, maybe your site reliability folks, right? This is the type of stuff that you can bring to the table now. You can pull up the dashboard. You can even hand them these URLs. This is just another URL. It's an HTML5 app, and you can hand this just like we do in the Slack notifications, just like you can send this in for email. You can do that as well. So in this case, we've got the load infrastructure. We're also directly monitoring the database at this time. We want to connect directly to the database to get things like, for instance, the number of full join blocks, if we're worried about that, if that's something that's occurred in the past. Also, if we see a linear progression of, let's say, non-cached queries, we know that maybe there's a part of our system that's causing a lot of queries that can't be cached to occur, something like dynamic SQL, which itself is a problem in many cases. Down on the bottom left, we have metrics coming from an APM tool, an application performance monitoring tool. In many of our organizations, we're starting to see that people will use their APM tool like Dynatrace, New Relic, App Dynamics, these kind of things, to actually monitor the infrastructure of a pre-release or pre-production environment at the same time, because they're getting the same value, the level of granularity out of their other environments, not just production. So if you're in the performance space and you don't have access to the APM tool, or maybe there's folks who haven't quite thought that they should extend their application performance monitoring to pre-production environments, this is a tangible conversation we can help you with to increase the level of visibility. And we have integrations to all the major names here. So not just what load you're putting on the system, what is the pressure you're putting on the system, but also some of the impact on the system that you have. But this is just a partial view. A lot of load testing solutions just give you a bunch of metrics and hope that you can make sense of this. Now, I would actually argue that this is not a complete view unless we have the last and final piece, which is how did it really feel for the customer? How did it really feel for the user? What was going on in the browser? What browser as we were going along? Now I'm feeding this by driving this
with Selenium scripts. And we'll get into that later when we talk about how that works. But in essence, it's measuring the certain transactions and the timing on certain transactions as they exist by running these against a grid where you can actually see that some of these sessions are actually running in browsers here. So we're actually running through a functional test, collecting metrics about the functional test at the same time. And that's the timings on the transactions here are streaming back into NeoLoad. So this is the complete view that we want to get to, but the question is, how do we reliably do that in continuous integration? And again, we go back to the notion of if it's not code or if it's hard to change dynamically, it's going to be very hard to right fit into your pipeline. So with that, I want to switch over to a couple of examples of how this stuff is actually described in code. Pull this up here and take a quick look. We were using a Jenkins pipeline, and this is the first place to go, execution, right? How do you execute these tests? Now I'll skip over some of the infrastructure setup using that Docker stuff that I talked about earlier, and we'll jump right to the place where we actually want to execute a NeoLoad test. And we have a Jenkins pipeline plugin that allows you to describe in declarative code what project you're trying to run. That's this line here, right? So what's your project? In this case, I'm pulling in a project directly from Git. So our low-code tool that our basic testers use to craft these things out, well, they can save this in a source code repository system like Git, or we also support SVN. And that way I can pull it down into my CI system. The second thing that we do is we actually want to point it to additional files, called, YAML files, that describe our tests as code. So there might be some basic tests that are in our basic project, but we also want to dynamically overlay this new test as code stuff that we're doing. And then there's a few other parameters of how to throw the metrics up to NeoLoad Web and so on and so forth. We also handle enterprise licensing in such a way where you can tell these scripts to use a shared pool of VUs that's dedicated for CI. So you're not having to step on other people's toes when you're utilizing the license or when you're utilizing load infrastructure. And that's where we're moving towards in 2019. The more we have people automatically executing these things, the more we need to be dynamic about our infrastructure, and the more we need to provide safe places for people to utilize the resources that other systems aren't using at the same time. So this is the kind of stuff that we've been working with customers directly to really flesh out in large scale. And it's represented in our product. Now this overlay YAML file, what is in here? What's going on with this? Well, here's an example of one of those things. I built out a little example here that describes a little more in detail what might be going on. I'll bounce between this test as code example and the graphical interface. I hope that this isn't too disruptive to people, but I think bouncing back and forth to describe what we're seeing in relation to what we used to see is useful. So the first thing that you want to see is, at a high level, we support a significant portion of the basic functionality in NeoLoad today through code. We're continuing to roll out support for various edge cases and special cases. Building a product for 10 years like we have, having the complete view in the graphical interface with all sorts of great things like advanced actions to do like MQTT stuff, all this kind of stuff. It's going to take a little while to port over to our test as code, and quite frankly, we don't know what matters to people until we actually start using it and until we have those conversations with customers. So what we want to do is, like the lean folks, like MVP, minimum viable product, we really want to make sure that we hit the minimum that we have to in order to make a viable product for API early testing. And that's what you'll see here, is a subset of the functionality available in the low-code graphical interface. So this first part, variable, very important to be able to bring in data from previous, maybe like lists of users or data elements that you use, like search queries, those kind of things in your load tests in order to vary the traffic in such a way that it exercises your application and all the caches and things like that along the way. Very important. So in order to bring those in, we've got a couple of examples here. There's a high-level section called variables, just like there's a high-level section for all the other main elements of our load testing model. The variables, you can have a constant variable, and you can have file variables come in. We're looking to support other things like SQL in the future, coming soon. But in the meantime, this maps directly to what you typically see in our variables manager here. So an example of the static items here, we would probably have maybe a path to something specific, or an API key, or maybe what target server you actually want to hit. These are the types of things that you typically create variables for. And oh, by the way, lists of elements. So like usernames, passwords, those kind of things that you need to test your application. So that directly maps to the notion of variables in NeoLoad. Servers, same thing. We want to reduce the number of times you're duplicating effort, and the notion of servers in NeoLoad helps you accomplish that. So rather than having to change this in 150 different requests just because maybe an IP address changed, the target server changed, we abstract that notion into servers. And then we provide you one place where you can go and actually change that, and it'll change it everywhere in your script. Makes it really easy to do so. This isn't, you don't need to search and replace a whole bunch of C++ code. Let's put it that way. The same thing is true in test if code. Test if code has the notion of servers that you specify things like what the actual server name is. In this case, there was a host that's a third-party geolocation lookup call in these examples. And in this case, if I needed to change that, I could just change that here. And then I don't have to go through all my user paths and change it everywhere, okay? So same notion applies. We're really porting over the efficiencies that we find in our approach in the GUI, the graphical interface, into our test as code approach by doing this. And now comes to the most tricky part, which is the user paths, right? These user paths, what we call user paths, or in other terms, virtual users, in some cases scripts, other people call them scenarios. The goal is to provide the same level of support eventually that we have when it comes to the graphical interface here to describe what a virtual user is doing at any point in time. Those scripts or user paths are broken down into a couple of containers here, the init, which is the startup, and the end, which is the teardown, and then actions, what happens during an iteration of that virtual user. Those can be broken down into transactions. Those transactions can have pages and containers and requests in them so that you can start to categorize rather than a whole big list of who knows what coming from your actual application. You can actually start to contextualize what a certain portion of traffic is about, what part of the workflow that relates to. That's what transactions are really useful for. Now, we have the same notion in test as code. You can see that we have a simple user path here that is called API save search. There is a transaction called obtain OAuth token, which means that we have to reach out to some asset that's part of the application to go grab a special token that happens to be called the OAuth secret, client secret. We want to store that into a variable so that we can use it later on when there's another request that needs that piece of information to be valid. In that way, just like our typical extractors, right? When we do an extraction here, there might be an example here where we go and extract a variable. People who are familiar with the ease of use in our graphical application do variable extractors, right? Would be this kind of dialogue where it makes it easy to build these things. Well, in code, it's just as easy for folks who are familiar with this model to extract those kind of notions into the next step here, so that we can use it in a later request. This just needs to have it as part of the body for that to work. Then we can also do further extractors and so on and so forth. So as you can start to see, we have not only variables and servers and user paths, but we also have the definition of populations here. Populations are a way to take those user paths and be able to actually run them on in various different quantities or ratios, and then also potentially pin them to different geolocations or specific hardware that should be sending that traffic when we go and run the test. So we can express those here just the same. Now, this example is very one way about certain things. I'm only doing a 50% distribution here, but if we actually look at some of the documentation, our team has done a really great job at documentation over the tested code stuff. You'll see the same notion that I've been going through is in our GitHub repo. And we'll be sending these links out so it makes it easy for you at the end of this webinar, after the recording processes, within a day or so, we'll be sending out an email that contains some of these links. So don't worry about the fact if you don't see something that you typically see in the graphical interface, we'll get there. We'll get into that. And if you have any questions, feel free to put them in the chat. We'll also follow up with questions that we can't cover immediately in this hour. The last thing is scenarios. And this is one of those ones that has, you would not believe how much power this packs when it comes to right-fitting the tests into a CI pipeline. Scenarios are the construct that allows us to control how much and over what period of time we run various populations. If we go back to the product here, that directly correlates with these screens, okay? So here's our scenarios, here's our populations. When we create a scenario to have a population, we need to tell it how long to run or how many iterations to run, how to ramp itself up or maybe stay constant or do peaks. That's the load variation policy, and then the load generators. We have the exact same notion in scenarios here. And in fact, later on, I can show you the example of how to vary the load generators too. So pretty much anything you can do in NeoLoad, starting with the basic functionality, you can vary in files like this, okay? So when we go back to that notion of the pipeline, when we're running an example here, like a basic project, which might include direct monitors, right? Which might include that advanced functionality we haven't quite ported over to test this code yet. You can certainly reference what you have in the main project from your test this code YAML file. But the example is, it's not just one YAML file. You might not just have one YAML file. We allow you to overlay YAML files on top of your project, as many as you want. And why is this so useful? Well, because if you think about this, the user path, even a simple user path, can take a little bit of lines away from the simplicity of one of these tests, right? There's a lot of descriptors to things like advanced requests. So the fact is, you could actually break out your user paths into individual files and then only bring in the ones that you actually need when it comes to your pipeline. So in this case, I'm bringing in a static file that I have as part of this project. And oh, by the way, if you can also add these to a subfolder of a project. So obviously the user paths are in the project directory, like we normally used to see them. But where do you store these YAML files? Just store them in the same project directory that you typically use as a NeoLoad project directory, right? If you're Git versioning that, it's going to go up there too. It's going to include those files too. So no problems there. In fact, this is how I wrote this example, that you've got some basic YAML files that are static, like what you just saw now in the other file. But think about it. It's just a file. It's just a text file. We can write these things dynamically. So let's go back up a little and see an example of how I'm writing this stuff dynamically right along in the pipeline. Here's an example of the Jenkins pipeline, a previous step that sets up a file that actually dynamically writes a file to the workspace whose contents are one of the sections that adds a scenario to my project so that I can run that. Why would I dynamically drive this? Because maybe I want to parameterize things like the duration. Maybe I want to parameterize things like how many threads or how many virtual users a particular population uses, right? This is the type of stuff that allows you at the top of your pipeline to pull these important configuration knobs and switches out and be able to very quickly fit these things in. So in this case, you can see that I'm using 2 or 3 Selenium threads here to run my end user population, the stuff that you saw come out in terms of the data points here, right? You can also see that I'm actually running the end-to-end test for 10 minutes. and I'm doing the sanity check for just 1 minute, and that the license that I'm going to check out for this would max out at 50 VU, just for the sake of demonstration here. You can control these things dynamically if you use things like variables in your scripts here. So I think I've covered the Jenkins pipeline as code, what we have available there, built in. Also, if you're using Bamboo or TeamCity or CircleCI or any of the other big players there, essentially, even if we might not have a pipeline as code command, we still can run as a CLI call, a command line call, like what you saw here. It's actually not that complicated to derive, let's see, this thing right here. It's this part, right? That's really the most that you need to do to put into a shell script to call out to your system. So, circling back on one or two notions as we start to round down the hour. We've talked about pipeline as code. If I go back to some of the slides, we've already started to pre-cover a couple of other concepts. Think about the impact of being able to express your tests in a way where, look, your devs don't even need to load up NeoLoad to see what might be going on in an API test. They can help you see sometimes what's missing if all of a sudden your tests start breaking because they introduced a new token. You can collaborate with them on the test as code to show, hey, this is what my tests look like today and they're breaking. And then the person can go, oh, well, that's because we added this new token. Oh, okay. So the transparency is really important. But the idea is to be able to have a lot of the right people in that process, right? The whole is greater than the sum of its parts. Kristen, you know, in terms of the collaboration piece.
So, going back to the bimodal, environments that so many enterprises have, collaboration in terms of how we integrate with tools, not only on the left, but also on the right. So we continue to upgrade how our data exchange API works with APM tools. So for example, you could see here in this screenshot that, actually this is a live demo,
yep.
How we're integrating with Selenium functional performance data alongside with Dynatrace APM data, and you can see the performance data all in one screen. So, and this is bidirectional. You can also view NeoLoad's performance data within the APM tools using this data exchange API. And this is all available for existing customers. You're already used to getting this within NeoLoad's GUI. This is all now also available in 6.8 in NeoLoad Web. And this just makes it easier for teams to collaborate amongst the same testing data in one visual.
That's right. That's right. I totally forgot about the whole single source of truth thing, right? Your load testing and what happens on the server should share the common source of truth. Doesn't mean you'll only have one way to visualize that. In this case, I logged into our little Dynatrace account here to show you how there are some specific metrics that are being reported at various time frames here based on the testing that we were doing just now. So this is an example of some of the NeoLoad metrics being fed into the APM tool, so you can graph them along with any of the other big metrics from a whole slew of different layers that the application performance monitoring tool has access to. Maybe that traditionally you didn't, as a load engineer or as a performance engineer, didn't always have the luxury of getting in your tests, right? It would be a compare this report to that report kind of thing from two different business units. Well, now you can actually overlay those reports right together. You can have the JVM thread count right over your performance data and notice that there's a specific issue here with the runtime launcher of our Apache system. So we can start to very quickly infer that and get closer to where the thing is, but it depends on which view you're in, right? So we need to be able to have not just a bimodal, but the multiple views on the same data. And that's why I say the single source of truth about the load that was put on the system and what was perceived like about basic response times, that's coming from NeoLoad, and it should be the same when it's streamed to Dynatrace as when you're visualizing it here and pulling Dynatrace information back in. So that bidirectional thing works really hand in hand. So we've talked a lot about this data exchange API, but essentially we've had this for a while, and what now you can do is be able to share this out with the whole team and be able to integrate data from various external entities, things like Selenium, APM tools, our direct integrations. You could also stream in your own metrics directly into that view. And the benefit here is that obviously we're sharing the results to the organization, but to be able to consume that in various ways and to also not have to second guess what time frames and what's the context behind what we're seeing on these dashboards, when it's the same source of data, it's very easy. And the idea is we're trying to reduce that mean time to resolution. Not just mean time to resolution in some fire in production, but even before production, when we catch an issue early, what do we do about it? How actionable is it? And so with NeoLoad and with the APM tools, we're able to make very actionable what's going on without, even before release. So a couple of other things I want to touch on really briefly. You might have seen when I was running the tests that I was using Git. And obviously, we want to fit within the tool landscape that people have chosen. There's a lot of folks who have decided to go with Git, whether it's GitLab internal, whether it's GitHub hosted, whatever it is. Fact is, Git has become pretty much a dominant player in the source code management system space. So what we've done, we've had Git integration in our product, but we've enhanced it with the ability to create branches directly from our system. This really helps when people are sort of experimenting with different load tests and they want to go off on a branch and tweak some things, change some things around. They're not quite sure they want to commit it to the main line, particularly a main line or a master branch that's used in continuous integration. So in this case, we're able to do that, and the easy way to show that would be over on a system that has NeoLoad proper installed here. The first thing we would want to do is check out a license that allows us to do integration and collaboration. So it's just as easy now to be able to use either an existing license or an NTS server, a NeoLoad team server for licensing, or the web. And we'll go and really quickly lease that license out here. This is a thing that a lot of people who are familiar with the tool already do. Of course, I have a little bit of screen issue here. I'll try to click the OK button. There we go. And now that gives us a couple of options around collaboration. The first thing is that the collaboration preferences can point to a Git repository now. So a Git repository here, we've got a tiny little example, and it allows us, without knowing anything about Git, the command line tool, for teams who haven't gotten through that training or aren't familiar with command line tools, eventually, people who are in the Git world eventually get familiar with that. But starting and onboarding may be a problem. So we provide a way to clone a repository directly from the product. For instance, in this case, we reach out to that Git repo and we find that there are 2 branches. And we can select a branch that's appropriate to us. And then we pull it down and it opens the project up for us. We can then make changes and push back to that branch. So in this case, we're really starting to build into the same set of tools that potentially product teams, development teams are using for their application code. Well, now we're able to do all of the project source files and also match various versioning strategies and branching strategies at an organizational level, bringing the product, the performance teams, and the testing and QA teams into more of a modern approach to be able to do this if they're not doing it already. In many cases, in my larger customers, they're already done moving to Git. They're already dealing with that. They're moving into issues at scale, this kind of thing. So they're really looking to this, and that's why we're providing support here. So as you can see, we've checked out our project. We can also do that obviously in the pipeline as well. As you see right off the bat, it's checking some Git repositories out. This is something that tools are already familiar doing, and it's not like we have to recreate the wheel from the pipeline code approach. That's already handled in typical pipelines to be able to check Git branch out. The other thing that you might have noticed is I was getting Slack notifications. So in this case, I've got a notification in Slack that showed up when the test passed, and it even gave me a little graphic, just a high-level graphic of, hey, you know, sanity check, does this look right? Right? So it passed with no errors, but it also gave me a little graph and a little detail that's fully dynamic. This dynamic mixed scenario was the one that you saw that I had dynamically written to the workspace and run in real time. So in this case, we can actually go to that overview right from Slack. And underlying this whole notion of Slack getting notifications, or maybe it's Skype, or it could be HipChat, or maybe even some other system like an email or a text notification, maybe through something like Signal, through Twilio. If you're already hooked up with various APIs, there are systems that allow you to set up a webhook. And if we switch over to NeoLoad Web, you can see that you can switch over to the account and webhooks. And I've got a couple of webhooks built here. We've got documentation on this, so don't worry, you don't have to like scramble to try to figure out what the code is here. But I've set up a webhook on one of my Slack groups that's specifically built towards a channel that allows these messages to flow through. This is the hook URL, and this would be the payload. If you notice, the payload has a couple of placeholders here, like test scenario. This is how we're feeding information in to make it visual in Slack. So in this case, there are two types of webhooks, one when the test starts and one when the test ends. For now, we're also looking to build this out in the future. So if you have suggestions, let us know. You can also filter by maybe project name or even scenario name, like that dynamic scenario that we created. If I just want notifications just for that specific job, that nightly build, that particular product team that constantly runs performance tests and runs into issues, maybe I want to know about when they're kicking things off, you can do that easily, very easily. What also comes through is some advanced information about the test once it's done. So the information that we have beforehand and afterwards is slightly different. And that's what you see here is an example of the payload that gets sent to Slack when we actually do that. And it includes the graphic overview. So this is an example, and you could use, you know, if this then that to drive logic. In what format, over what type of communication system they'd like it. There's almost always a way to be able to use webhooks to push that conversation forward. The documentation we have, we'll send the link out as well, and it's all here, it's all available, as is that original test as code stuff. So don't forget, we'll be sending these links out as well. And then the last bit we want to touch on real quick is the fact that as a whole, we're really touching both sides of this kind of situation here. We work with all sorts of people, right? All size companies, and the more we're able to expand to meet the needs of the enterprise, the more we realize that they are also expanding and adapting their approaches to how they do software development and how they do testing and feedback to fit with this more modern approach. So we have to do both, not just for one type of organization or another, but we get to do it for both. So at this point, we've seen how we do some stuff around SAP. We very, very briefly touched on that. The reason is, quite frankly, it makes more sense for you to first hit the landing page that we have that has a 5 to 10 minute video overview, and then directly call out to us if you're interested in starting it on a POC or working with a demo directly. That makes a lot more sense than me going through that detail here. As you can see, there was a lot of content today. We talked about that data exchange API and how it really provides end-to-end metrics. Then also the notion and the motion of going, shifting things around and being able to fit into modern development and testing cycles together. And by that, we're able to do test as code. We're able to do Git branches now, and we have support for webhooks. And
yeah, and Paul, just to wrap up, you know, with mode 1 and mode 2 up here again, we're just reminding everyone that NeoLoad is about testing everything from your APIs at your tester and developer workstations all the way to, and that's shift left, all the way to shift right, which is, you know, integrating with all your other tools in your enterprise stack, and collaborating with other data, and bringing in other test assets and converting those into performance tests so that we're doing the work that you don't have to repeat.
so, what's the next step, Kristen, right?
There's going to be a survey that's going to be available to you guys after this for 6-8. And we'd love to, you know, if you guys want to get your hands on this, the trial's available at neos.com/trial. And of course, you know, we'll be reaching out to you, but if you want to hear from us sooner, you're welcome to contact us and talk to our account managers.
Yep.
And we look forward to working with you guys more. There are a bunch of questions that were in the chat. I think Paul will probably follow up offline about those since we're at time at this point.
Absolutely.
But I have noted them, and we will follow up with you guys.
All right. Well, thank you, everybody, for taking the time with us today. I know that there are a number of customers who are near and dear to my heart. We talk all the time, as well as folks who are still looking to make a switch. So I appreciate everybody's time, and to the partners as well.
All right.
Thank you.